Okay guys, so this is the boot camp about enthalpy. We'll start with one on enthalpy profile diagrams. There's basically two types of diagram you can draw, an endothermic or an exothermic. Be very neat and careful with these, as you will be penalised if your arrows don't go exactly from the dotted line to exactly where they're supposed to go to. So boys, I'm thinking about you now. Bring a ruler, do it neat, no scribbly half-assed diagrams there please. So look, cover, right, check, repeat, 5 minutes, off we go. As well, just to point out, that sentence in green at the bottom is definitely worth remembering as well, because one of the biggest mistakes with this is people who get the arrows the wrong way round. So if you remember that sentence at the bottom, arrows always point away from the reactants, that'll really help with that. Okay, guys, so that is our first one on enthalpy profile diagrams. The next one, this one's all about Hess cycles. There's two types of Hess cycle, where you'll be given the enthalpies of combustion and one where you'll be given the enthalpies of formation. So you'll know which Hess cycle to use by looking at the data given to you. There'll be a table with loads of values in. If the title of that table is delta HC, then you're going to find it bloody difficult to use enthalpies of formation, so you've got to use combustion. If the title is delta HF, then you've got to use enthalpy of formation. So, 5 minutes, off we go. Three minutes left, guys. Hess cycles is a really big topic, comes up all the time. It's also going to be most likely in one of your assessed practicals, as they're all to do with enthalpy. So definitely worth learning. Keep going, guys, halfway there. Okay, just 30 more seconds left, guys. Keep on going. Remember, with combustion, the arrows point down. Think you burn a house down. With formation, the arrows always point up. So with combustion, you'll always flip the enthalpy of the right-hand side. Whereas formation, you always flip the enthalpy of the left-hand side, because that's when you'll be going against the arrow. Because with formation, the arrows point up. Okay guys, and that is that one done. This next slide's all about 3 definitions, quite long there. The key thing to remember for both combustion and formation is they're to do with 1 mole of stuff. With combustion it's 1 mole of fuel, with formation you're making 1 mole of compound or thing. So guys, 5 minutes, off we go. Halfway through guys, keep on going. Remember that little theta sign, the little 0 with a line through it, that means under standard conditions. So if ever you've got that, you've got 298 Kelvin, or 25 degrees C, 1 atmosphere, and if you've got solutions, they should be 1 mole per decimeter cubed. And then everything's in its standard state, as the definition says. 45 more seconds left. You can do it, guys. Try and get it down another 2 or 3 times. The more times you write it down from memory, of course, that's the best way to learn it. The more times you write it down from memory and then check your answer, the better a chance you stand at remembering it and not missing out a few key words in the exam. These definitions would be 3 marks each, so if you was to get 2 of these in the exam, that's 6 marks. That's almost a grade just on learning these 3 different things you could get. Okay guys, and on to the next slide. So second to last slide this is calculating delta H using the MCAT equation. Really important to remember that the heat equals MC delta T is about the surroundings, and therefore when you do the delta H equals the heat over the moles, you need to flip the sign of the heat. So let's say when you did heat equals MC delta T, you got your heat as plus 50. You would need to make that minus 50 when you're doing your delta H equals heat over the moles. So flip the sign. I'll put common mistakes down the side as well. Don't forget, in your heat equals MC delta T, do not use the mass of your chemicals. You've got to use the mass of your surroundings. Don't forget to flip the sign. You can always check as well whether or not your delta H will be negative or positive by thinking, is your reaction exo or endothermic? Obviously exo would be negative. The way you'll know whether your reaction is exo or endothermic is by looking at the temperature change. If the temperature change is positive, then your reaction must be exothermic and your delta H must be negative. Don't forget about units as well. You need to divide by 1,000 to get into kilojoules, and don't forget your temperature change can be negative. So delta T is not always a positive number. Okay guys, so about 4.5 minutes left, off we go. Keep going guys. If you remember the common mistakes, then you'll be less likely to make them. And these are mistakes I see all the time when I'm marking people's homeworks and past paper questions, especially that first one. That's really one to watch out for. So keep on going, look, cover, right, check, repeat, repeat, repeat. You can do it. 1.5 more minutes left, guys. Think of England, you can do it. Right, okie dokie, guys, and for the final slide, my good friend, the Mexican wrestler Bendo Mexo, who's good at bending things. Breaking bonds is endothermic, making bonds is exothermic. I've also popped at the top there the equation you'll need if you're trying to calculate delta H using given bond enthalpies. As breaking bonds is endothermic and you need to break the bonds of your reactants, you need to add, as in positive, all the bonds of the bond enthalpies of your reactants. As making bonds is exothermic, so negative, and you need to make the bonds in your products, you then need to subtract the bond enthalpies of the products. With this, with bond enthalpies, the biggest thing to remember is you must draw the molecules out. Draw the displayed formula. The reason you need to do that is because although it sounds like a really simple calculation, everybody always gets it wrong because they miss bonds out. If you draw out all of your molecules' displayed formula and then cross out the bonds as you write them down, that way you won't miss any bonds out. So, about 4 more minutes left, off we go, guys. About halfway through now, guys. Last year I knew a student who did this slide and managed to copy it out 15 times. Next day he developed X-ray vision. I'm not saying they're connected, but it's definitely worth thinking about. Okay guys, just try and get down one more time, 30 more seconds, off we go. One more time. I'm going to be really interested to see people's takes on drawing Bendomexa. I think I might give a prize for the person who's done the best picture of him. And that prize will be my respect. Okay, that's it done guys. Thank you very much. I'll see you next week.